Hello everyone. I have come up with the series on the application performance, how we can improve the application performance by reducing the latency at various levels. Now, the latency could be present at any kind of level. When I say level, it could be present on API servers or it could be present on the database servers. Now, this is the first video of the series. So here we will see how we can avoid latency or how we can quickly fetch the data from the database in a quick way, right? Now, जब भी हम application performance की बात करते हैं, so there are two ways to approach this, right? First way is either you can go top to bottom. When I say top to bottom, it means firstly we go and check the API servers where the API is taking time, which method is taking time, and slowly we'll go as and when we move deeper we find that okay, this database or this query is taking this much time. So in this first video we'll see the practices we can follow uh, for the database to fetch the data or insert the data in a quick way, right? Now the first thing, as you must have known, that is the indexing, right? So first thing is the indexing. You might have already seen that, right? Now let's consider a very simple table, right? Table is the users table where we have the five columns: id, username, email, is active, last login, right? So this is a very simple users table, right? Now consider this users table is of any kind of social media app, for example the Facebook or the WhatsApp, or you can say Instagram. So there could be millions and billions of users in this table, right? Now you can also imagine that, for example, आज मैंने इंस्टाग्राम ऐड किया है और मैंने अपना अकाउंट क्रिएट कर दिया इंस्टाग्राम पे, राइट? मेरी एंट्री क्रिएट हो गई. It could be possible that I am not using Instagram for you know uh, for 1 year now. मेरा अकाउंट तो बन गया है. It could be possible कि मैं यूज़ नहीं कर रहा हूँ उसको. सिमिलरली फेसबुक का है, मेरा अकाउंट बना हुआ है, मैं यूज़ नहीं कर रहा हूँ. तो होता क्या है कि ये जो यूजर्स टेबल है या फेसबुक एप्लीकेशन है, ऐसा तो नहीं है कि वो यूजर्स टेबल को मेरा डाटा डिलीट कर देंगे. ऐसा नहीं है. अगर मैं 1 साल के बाद भी आऊँगा और मैं उसी यूज़र आईडी से लॉगिन करूँगा, तो दे माइट रिक्वायर री-ऑथेंटिकेशन और सम काइंड ऑफ अदर मैकेनिज्म, बट द पॉइंट इज़ कि मेरा इन्फॉर्मेशन ऑलरेडी तब भी उनके पास होगा. सो इट मीन्स कि इस यूजर्स टेबल में देयर कुड बी सम active users, some inactive users, right, which are not present on which are not currently active, right? Now let's go with the first challenge. What we need to do here is we need to find the active user by username in a quick way, right? Now what all you think, okay, what all you think the most common solution which people follow is by creating the composite index, right? So they will create the composite index, and this is the very, I'm considering, we are using the Postgres, I'm assuming, right? So this is how we simply create the index on any of the column. Composite index, when we say, it means that the index is present on more than one column, right? So then it's called composite index. Now composite index has been created on the username and as well as the inactive. Now what would happen here is, as and when the insertion would happen with the username, the following particular table, right? तो उसके अंदर is active true के साथ भी एंट्री हो जाएगी, right? बट पॉइंट इज कि इसके अंदर जो है, ये जो इंडेक्स है, इसके अंदर बहुत सारे यूजर्स हमारे ऐसे भी हैं जो एक्टिव नहीं है. दैट मीन्स उनका इज एक्टिव फॉल्स होगा. माइट बी सम क्रॉन जॉब इज रनिंग एट द बैक एंड which would check, okay, this user has not done any kind of recent activity in the last one day or 2 days. So might be वो cron job उस यूजर को इनएक्टिव मार्क कर रही होगी, राइट? सो द पॉइंट इज कि इस यूजर टेबल में इनएक्टिव यूजर्स भी बहुत सारे हैं और एक्टिव यूजर भी बहुत सारे हैं और बहुत सारा डाटा है, बिलियंस एंड मिलियंस ऑफ यूजर्स आर देयर, राइट? नाउ इफ यू गो दिस वे, right, the composite index way, now there are two downsides for this. First downside is it would increase the disk space, because now the username has, for example, username is abc, right? Now is active is true. Similarly, some username is there like rahul, right? His, but he's not active. He's not active since last 1 or 2 days or last 1 month or so, but cron job has make this user as false. Now the downside for this composite index is the index would contain even the inactive users as well. But what you all know, what you, the query pattern is the challenge. What I mentioned here is you have to find the active user by username in a quick way, because for, let's assume, for inactive user you might need to re-authenticate, or might need to, you can say, some kind of re-authentication mechanism might be there. But for mostly frequently data, for most frequently accessed data, so you need the active user, right? So if you create the composite index this way, it would increase the disk space and also it would create the index size, right? So this is the trade-off. Although it would work fine, I'm not saying it won't work, it would work, but you would still face bit of performance issue, right? Because considering the large amount of data is there. So let's move towards the next approach. The next approach is index on both columns separately. You would say, okay, the next approach is you can create the index on username as well as the index on is active column, right? Now this is even more worse than the earlier solution, the composite index. What would the downsides for this? It would increase the disk space, and also if you see, there two index scan would run. First index scan on the username and the second index scan on the is active, right? And if you see that also the index size for this inactive users would also be there, it is even more worse than the composite index, right? Although both of solutions would work, but you won't get the great performance out of it, right? So now the best solution what you can do is you can use the partial indexes. Partial indexes are very very powerful. Now what you can do, it's a very similar to, you can see the similar to basic index, just you are creating index conditionally, right? So you have just mentioned the condition here that where is active is true, you are creating index only on username, right? But you have just mentioned the condition where is active is equal to true. So you can imagine the disk space has been reduced a lot, and also you would see the performance, right? You would see the great performance out of it. Now the index size also would be reduced, and the disk space also reduced, and you would get the great performance out of it. So this is the best solution, right? So but mostly I have seen people using composite index, but there is a partial index, it gets supported in the postgres, right? But there could be other databases where you can utilize the same concept, right? So this is where the best part lies, right? Now this second point is the you have to make the faster insertions or updations. Now let's consider the simple use case. For example, the Instagram, you have posted some photo or video, whatever the kind of, let's consider that you have posted the photo, and on every photo you need to count the views, right? How many views are there on that particular photo, right? Now there are two ways. What are the two ways? First thing, for example, as and when user enters, as and when user post the photo, right? So you have to make the particular insertion, right? Insert into photo views, right? Kind of that. You have to do that. Now, whenever the other user is seeing, you have to do the update statement. Now, for update, you have to know whether this particular photo is exist or not. Now, how to check exist or not? So there is only one way. You can do the get first, and then you do the update statement. So there are two statements. So firstly, you need to do the get, whether the particular photo exists in the database or not, and then you have to perform the update. Then you have to perform the count is equal to count plus 1, right? So if you see, for this update, you are getting the performance hit here as well, right? You are uh, hitting the two calls to the database, right? Firstly, you are doing the get, and then you are doing the update. So you can reduce this as well by upsert statement. Upsert statements are also supported by the Postgres. So it is also very simple. For example, you can use the insert similar as it is, but just on conflict photo id, you can just mention do update set view count is equal to count plus 1 if the particular photo id is already there, right? So you can directly do the count plus 1. So this is the most brilliant solution out of it, because you just are hitting the one call to the database at their side is handling, but you have offloaded the calls to the database, and now database is handling the update also along with the insert statement, right? This is one thing. But this the upsert statements are very very helpful in you in the idempotency request. For example, there is some system, right? There is some, for example, let's assume there is a transactions, user is doing transactions, right? And eventually what happens is user call the transaction service has its own database, and it makes the entry into this database with the user id, transaction id. For example, this is the transaction id, transaction amount, right? And then status, right? Date. This entry has been uh, logged into this particular database, but this change might be streamed to the other workers. There might be some interested other subscribers where we need to publish this kind of data, right? So what happens here is there could be a chance that the other services are not available at the moment. You have published the message onto the Kafka, but there could be chance that here you get the message twice, right? During the retries or any kind of thing, right? So here at the worker level, you have to make this particular statement idempotent, right? How you can make this idempotent is, you can simply at this worker level, you can simply do the upstate statement similar like earlier, right? And on conflict transaction id, you can just mention do nothing, right? With this, what would happen if the transaction entry is already been logged into this particular worker database, right? So the entry won't be logged again. So this is how the idempotent uh, you can make the system idempotent, right? So this is the second optimization or second uh, practice you should follow to make the application performant, right? Now the third point is partitioning. Okay, what is partitioning? Partitioning is dividing a large table into smaller, more manageable pieces called partitions, right? And for example, you have a large database, right? You have a large database, and you have large table actually, right? Large table where you have millions, billions of rows, right? But at the Postgres side or at the database side, what you can do, you can divide this table into smaller tables. For example, table 1, table 2, table 3, right? Now, as and when you hit the query onto the database on the condition, like on the where clause you have mentioned, for example, I'll explain in the example, you would specify one condition. Based on that, database would automatically route your query to particular smaller table, right? So this is how the partitioning would work. Now let's see the simple example. For example, the transactions table is there. There are 4 columns: transaction ID, amount, status, date. Now what you can do is, first of all, what happens here is, in the companies में क्या होता है कि हम एक cron job पहले से ही लिख देते हैं, right? cron jobs होती हैं और हमें पता है कि इस टेबल की हमें partitions चाहिए. We already know, pre-known, right? तो हमें फॉर एग्जांपल किसी एक टेबल है, उस पे डेट पे कोई पार्टीशन करनी है, और डेट पे भी पार्टीशन आप मंथ वाइज भी कर सकते हो, ईयर वाइज भी कर सकते हो, डे वाइज भी कर सकते हो. इट कुड बी डिफरेंट, इट कुड बी ऑन योर बिजनेस लॉजिक, राइट? तो होता क्या है कि हम पहले से ही कुछ क्रोन जॉब जो है वो क्या करती है, पहले से ही हम कुछ पार्टीशंस बना के रख देते हैं, राइट? हमने जब डिप्लॉयमेंट हुआ, ऑन डिप्लॉयमेंट इटसेल्फ, right, on deployment or installation itself of the complete system, what happens is हम पहले से ही एक इसी टेबल को छोटे छोटे टेबल में डिवाइड करके पहले से ही बना देते हैं. फॉर एग्जांपल, जैसे कि हम यहाँ पे देखें, create table transactions 2023 partition of transactions table, right, for values this to this. Similarly, transactions 2024 का एक हम बना देंगे. अब होगा क्या, कोई भी वैल्यू जिसकी डेट जो होगी, फॉर एग्जांपल 2023, राइट, एंड 10, राइट, 01, राइट, तो ये ऑटोमेटिकली कौन से टेबल में जाएगी, ट्रांजैक्शंस 2023 वाले टेबल में जाएगी. सिमिलरली, अगर मैंने कोई एक और पार्टीशंस बना रखी होगी, ट्रांजैक्शंस 2024, तो और अगर मैंने एक पार्टीशन बना रखी होगी, फॉर एग्जांपल रेंज मैंने डिफाइन कर रखी होगी 2024 01 टू 2025 01 लेट्स अज्यूम, राइट? तो अब मैं कोई भी एंट्री जो इंसर्ट करता हूँ, फॉर एग्जांपल मेरी एंट्री इंसर्ट होती है 2024 12/01, राइट, और यस. तो मेरी ये एंट्री जो है ये कहाँ पे जाएगी, मेरी जो ये एंट्री है ये जाएगी इस पर्टिकुलर स्मॉलर टेबल में. तो अब जब भी इंसर्शन होगा, तो इंसर्शन मेरा इस टेबल पे होगा, राइट, और मेरा सिलेक्शन होगा, तो सिलेक्ट करते टाइम भी मैं ये क्वेरी दूंगा, वेयर डेट इज इक्वल टू पर्टिकुलर दिस, राइट. सो दिस इज हाउ जो है पार्टीशंस इतनी इफेक्टिवली होती हैं. अब इससे बेनिफिट क्या हुआ, बेनिफिट ये हुआ कि अब हमारे इस टेबल के अंदर फॉर एग्जांपल 1000 रोज हैं, इस टेबल में फॉर एग्जांपल 1000 रोज हैं, राइट. तो अब हमें जो डेटाबेस जो टेबल स्कैन करेगा, वो सिर्फ इसी 1000 टेबल को ही स्कैन करेगा. इस बाकी वाले, देयर कुड बी अदर as well, right, or there could be, you can assume there could be 1 million here, 1 million here. बट अगर ये टेबल नहीं होता, अगर ये एक ही टेबल होता, पार्टीशनिंग नहीं की होती, तो डेटाबेस को 2 मिलियन रोज पे ट्रैवर्स करना पड़ता, स्कैन करना पड़ता, फाइंड करने के लिए कि कौन सा मेरा वैलिड रिकॉर्ड है. तो यहाँ से आपकी पार्टीशनिंग होगी. पार्टीशनिंग विद इंडेक्सिंग, you would get the best performance out of it. पार्टीशनिंग प्लस इंडेक्सिंग. तो अब इंडेक्सिंग के अंदर भी पार्शियल इंडेक्सिंग बेस्ड ऑन योर यूज केस, जो भी आप करते हो, इससे आपकी बेस्ट परफॉर्मेंस हिट होगी, राइट। नाउ लेट्स मूव फर्दर। द फोर्थ पॉइंट इज द मटेरियलाइज्ड व्यूज। अगर आपने देखा होगा जैसे बैंक स्टेटमेंट्स के अंदर कोई भी आपका कोई ऐसा यूज केस है जिसमें प्री कंप्यूटेशन चीज़ें चाहिए, जिसके अंदर काफ़ी सारी ऐसी है कि भाई हमें काफ़ी सारी प्री कंप्यूटेशन चाहिए, जिसके अंदर हम बार बार जो है वो सिलेक्ट क्यूरी हिट करेंगे तो डेटाबेस इज गेटिंग मीन्स database is getting overwhelmed, right? So for those kind of queries you can always use the materialized views. For example the बैंक स्टेटमेंट के अंदर अगर आपने देखा होगा तो उसके अंदर होता है कि लास्ट 3 मंथ स्टेटमेंट्स, लास्ट 6 मंथ स्टेटमेंट, राइट। तो ऐसा कुछ नहीं है, उन्होंने व्यूज बना रखे हैं, मैटेरियलाइज्ड व्यूज बना रखे हैं, जिसके अंदर की वो पहले से ही पूरा उन्होंने डाटा हमारा रिफ्रेश होता रहता है। तो इट्स वेरी सिंपल टू क्रिएट द मटेरियलाइज्ड व्यू। फॉर एग्जांपल जैसे हम नॉर्मल व्यू बनाते हैं, क्रिएट मटेरियलाइज्ड व्यू, और यहाँ पे आप इसको दे सकते हो। अब ये मटेरियलाइज्ड व्यू आपने फर्स्ट टाइम तो बना दिया, राइट। अब इसको रिफ्रेश भी करना पड़ता है, राइट। रिफ्रेश मीन्स कि जैसे लास्ट 3 मंथ्स का है, अब आज मैंने बोला कि लास्ट 3 मंथ्स का है, तो मेरा आज से लेके वो लास्ट 3 मंथ्स तक का डाटा बताएगा, राइट। सिमिलरली अगर मैं बोलूँगा कि मेरे को लास्ट 6 मंथ्स का चाहिए, तो मेरे को आज से लास्ट 6 मंथ्स का दिखाएगा, राइट। तो ये वाला जो है, ये इसके अंदर भी क्रॉन जॉब होती हैं जो कि सिस्टम में रन करती हैं, जो कि क्रॉन जॉब क्या करती हैं, इस मटेरियलाइज व्यू को रिफ्रेश करती हैं आफ्टर यू कैन से एट द नाइट 12 o'clock और समथिंग, किसी भी टाइम पे, जब भी आपके बेस्ड ऑन बिजनेस लॉजिक कि आपको किस टाइम पे वो व्यू रिफ्रेश होना चाहिए, सो दैट यू कैन survive with this tail data, right? So this is how you would get the database performance, and in the next video we'll see the application performance or the API performance. This was the first video on this series, and here we quickly discussed about what are the approaches, what are the best practices we can follow for the database to improve the performance. Thanks a lot.